Hello there, Gators. I hope that you guys are good and welcome to the second lesson on momentum and impulse. So today we are looking at Newton's second law in terms of momentum. Now, so the basic behind Newton's second law in terms of momentum would be you understanding what Newton's second law states, right? So as I've stated before that when following through the lessons, please make sure that you have your examination guideline for physical sciences grade 12 right next to you, right, so that you follow through using it, right? Okay, so now does Newton's second law state? So Newton's second law states that when a resultant force or a net force acts on an object, right, the object will accelerate in the direction of the force, right? So it means that if the net force is going to the right, therefore we are also expecting acceleration to be going to the right, right? So, okay, that is the basic thing here in terms of your Newton's second law, or Newton's second law in terms of momentum, right? Okay, so now let us check Newton's second law in terms of momentum definition according to the examination guideline. So that states, according to the examination guideline, that the net force is equal to the rate of change in what? Of momentum. So once we see a rate of change, we know that something is divided by time, right? Okay, so in other words, what the definition of Newton's second law in terms of momentum is saying is that the net force is equals to the rate of change in momentum. That is why it's very key to understand the definition even before going to the deeper context, because such definitions allow you to even follow through with the formulas and see where are they coming from, right? Okay, so please make sure that you understand the definitions of each and every heading when we start a topic, even before going further, right? So I hope that you're still following through with your examination guideline. So now one would ask, did they even come up with this concept of net force being equals to the rate of change in momentum? So now you'd remember in grade 11 that you were taught that according to Newton's second law, F net is equals to ma, right? But okay, what is acceleration equals to? So we know that acceleration and its definition is equals to the rate of change in velocity, right? Okay, so okay, now we can write this thing as F net is equals to mass times change in v over change in time, right? Okay, so now let us remove time. What can we remove time? We can remove time by multiplying both sides by the change in time. So this cancels out. So we are left with F net change in time is equals to mass times change in velocity, right? So now we remember that mass times time will give us what? Momentum. Therefore, we are now allowed to say F net multiplied by time is equals to the what? The change in momentum. Right. So I hope that this makes sense, right? So this is where the concept of momentum and in terms of Newton's second law comes from, right? I hope that you guys are following through, right? Okay. So now let us check this one here. So your Newton's second law in terms of momentum goes hand in hand with the change in momentum, right? So, okay, before we go there, it goes hand in hand with the change in momentum and again with impulse. But we'll be dealing with impulse in the second lesson. So for now, just focus on what we're discussing here. Don't move away from what we're dealing with here. Right, okay. So now that is your Newton's second law in terms of momentum. So what is the examination guideline saying next? It says that you must express Newton's second law of motion in symbols, right? So in this form here, okay, so this is how you should be able to express it. So I was just doing that in terms, when you now forget what your Newton's second law in terms of momentum is, you go back to this thing here again, right? I hope that I did not confuse you guys and this makes sense, right? So now they are telling us that again, we should be able to explain the relationship between the net force and the change in momentum, right? So now the relationship that is there between the net force and the change in momentum is that the net force and the change in momentum will always be in the same direction, right? I hope that makes sense. So if we have if we have momentum going to the right, therefore we'll have your net force going to the right as well. So that is the relationship between the two, right? I hope that makes sense. Then the next thing that we are asked to do according to the examination guideline is that we should be able to calculate the change in momentum when a resultant or net force on an object, net force acts on an object and its velocity. Right, so we should be able to calculate the change in momentum. So now that brings me to the second thing that we're going to be checking at, which is change in momentum. Right. So now what is change in momentum, or what is the formula for change in momentum? So change in momentum is simply equals to the final momentum minus the initial momentum. Right. Okay. So now we know that this can be broken down into its components. So we know that momentum is also equals to what? M times V. So it goes on further that mv final minus mv initial, right? So that is the same thing. And change in momentum is also measured in kilograms per meters per second. So basically it's still momentum and it's still a vector quantity. So that would mean that also in change in momentum, we also need to consider what? Direction. Right. So that's the most important thing now when we're dealing with vector quantities. Always consider your direction. Right. Okay. So let us now have just a quick example there. So let us say we have a tennis player, right? So this tennis player serves a ball towards his opponent, right? Right. So we have a tennis player tossing a ball towards his opponent. And let's say that the ball that he's throwing has a momentum with momentum of 11 kilograms per meters per second east. Ne? So that's the first part of the scenario. Right. Now, let us say that, okay, when he does that, now the opponent hits that ball back. So hits ball back in the opposite direction, right? Okay, so he will hit the ball back in the opposite direction. So you see now we are changing direction. So in the opposite direction, and the momentum of the ball changes too. So momentum changes to 8 kilograms per meters per second, right? So now the question would be calculate the change in momentum of the ball. So what are they looking for? Calculate change in momentum, right? So there are keywords you should be looking out for. If they're saying that something changes to, right? So if it changes to, it will mean that we need to calculate, or it will mean that something relates to the final momentum. But if they're saying it changes by, it will mean that that something relates to what? Your change in momentum, which is your delta P here. So Please note such terms. So now how would we calculate the change in momentum here? So the first thing we'll need to check, okay, is that on the first part, we have a ball being tossed at 11 kilograms per meters per second east, right? So that's the first thing that we have here, right? Okay, so we know the formula says that, okay, change in momentum is equals to P final minus P initial. So what happens initially? There's a player tossing or serving a ball at 11 kilograms per meters per second, right? So that's the first thing that happens. So we need to decide direction. What are we taking east as? So usually we take east as positive, right? So we're going to take east as positive, meaning anything going in the opposite direction would be a negative, right? Okay. So in this case, since we're taking the 11 as positive, now it means that when the opponent hits back in the opposite direction, right, that answer must be a negative, right? Okay, so they're saying, so it means that in this case, this will represent your initial momentum because this is what happens in the beginning. Now they are saying the opponent hits back in the opposite direction and momentum changes to 8 kilograms per meters per second. So that would mean that is the final momentum, right? Okay, so we can say now, okay, change in momentum is equals to the final momentum minus what? The 11, which is the initial. So the change in momentum in this case would be a what? A negative 3. Right, so 9, 10, 11, yes. So that would be a negative 3, right, kilograms per meters per second. But remember, when you write this momentum, don't include the negative. This just tells you that this is in the opposite direction. So in other words, we would say that momentum is equals to 3 kilograms per meters per second in the opposite direction. In the opposite direction or west. Right. So I hope that this makes sense, guys, and I did not confuse you at all. So sometimes they won't give you the full momentum, but they will be giving you the velocities. So now you need to be able to break these things down and calculate the momentum or whatever they're asking you to do. But please make sure that you first analyze the scenario even before coming to calculate so that you understand, okay, what is the final what is this thing, final velocity, what is the initial velocity, right? So it makes sense in that way, right? So I hope that this video, guys, was very helpful to you and you now understand Newton's second law in terms of momentum and change in momentum in terms of how it works, right? So join me on the next lesson as we go on and tackle your law of conservation of momentum, right? Please make sure that you share this video with others. Make sure you subscribe to all our channels. You follow us on TikTok, on Facebook. Please, guys, make sure that you support this so that everyone gets to understand physical sciences much easier, right? So that is our goal at Tutorials, that these subjects that seem to be difficult or that look difficult to others, they are made easier, right? Okay, so thank you, guys. See you on the next lesson.